Okay, so this is a problem on momentum principle, and I am using a spring with a block extended vertically with a mass of 0.5 kilograms. So the spring stiffness is, I'm using K, and that's 80 newtons per meter. The spring is extended vertically, and the block is hanging with a 0.5 kilogram mass. So air resistance brings the block to a stop, and it's now hanging motionless. So I found a picture online that say the spring is up here, and then finally air resistance kicks in and it brings it to a stop. So now it's hanging here, motionless. So the change in the stretch of the spring is h. So using the momentum principle, how much has the spring stretched? So since it's hanging motionless, I can remember that the change of momentum is actually 0. So I have to keep that in mind, and now I'm going to use the momentum principle to find out what h is. So momentum principle states that F net equals delta P over delta T, so F net equals the change in momentum over the change in time. So now that I have that, I want to use my block as my diagram and figure out what's in the positive and what's in the negative direction. In the positive direction, I'm going to state that the spring is being pulled up. The spring is being pulled up. So since the spring is being pulled up, we're going to say that's in the positive direction. And that is going to be the spring stiffness times the height. And that's in our positive direction. And the negative direction, we're going to have the Earth's pull, which is mass times gravity, and since that's in the negative direction, we need a negative sign. So now that I have that information, I know that F net equals the force of the spring plus the force of the Earth, and F net is going to equal 0. So that needs to equal 0. So with that information, I can have the stiffness of the spring times h plus the force of gravity, which is in the negative direction, equals 0. So I'm trying to find out how much the spring has stretched, so I'm trying to find h, because that's the change in the spring from the beginning to the end. So since I'm trying to find h, I need to add mg to both sides. So adding mg to both sides, I get this times h equals mg. And now I can divide by the stiffness, and that is the height equals mg over the stiffness. And again, all this happens because the vector sum equals 0 and it hangs motionless. So since it equals 0, I can just find what h is fairly quickly. So now I can plug in my variables. H equals 0.5 kilograms times, that's the mass we need, times gravity. So that's newtons per kilogram divided by the stiffness, which is 80 newtons per meter. And now I'm just going to check to see if my units will equal meters, since meters is what height is in. So meters equals, so kilograms times Newton over kilograms. Kilograms cancel out, so we have newtons. And now newtons is over newtons per meter, and now newtons cancels out again, and we have meters. So I can go forth with this, and now I have, through my calculator, that the height equals 0.061 meters, and that would be our change in the spring stretch. So that's how much the spring has stretched, 0.061 meters.